So let's go ahead and talk about validity before we move on for more bar graphs. So what does valid? Yes, some more bar graphs. So what does valid and invalid mean? So valid. So valid means possible, probable, or reasonable. So what it's doing is asking if this is a reasonable response. Is this an accurate response? So invalid is the opposite of that. It's saying, for example, which of these is not true? Which of these is not valid? And why is this important? So this is important because this terminology will be used on your test, and you need to be able to either choose the best option for valid or the one that does not make sense for invalid. Okay, so let's take another look at a bar graph. It says 3 boys and 3 girls ran for 7th grade class president. The boys are Andrew, Derek, and Miguel. The girls are Becky, Dora, and Trisha. The results of the election are shown in the bar graph. Which is greater, the percent of the total votes for boys that Derek received, or the percent of the total votes for girls that Dora received? So one important piece of information, so we're going to deal with Derek, but then it says total votes for boys. So we're not talking about the total votes overall, but just for boys. So first let's set up a ratio, and this is a part to part because we're not looking at all of the votes cast, we're just looking at Derek over all of the boys. So Derek had, right here is Derek, he had 135 over all of the boys. So let's see, Andrew was a boy. He is a boy. 75. Let's see, Derek is one of the boys. Bless you. At 135, and Miguel is one at 90. So you have those 3 boys added up. 5 plus 5 is 10. 7 plus 3 is 10. Plus 9 plus 1 is 20. 2, 3, 4. Is that supposed to be? No, it's supposed to be 3. I'm sorry. Can't read my own writing. So 135 out of 300. So we can set up our proportion equals x over 100. And what I'm going to do is just think about, okay, 300, what do I have to do to get from 300 to 100? Well, I know that I have to divide by 3, so I'm going to just go ahead and do the same to the top. So I'm going to do 135 divided by 3. So 3 times 4 is 12. Subtract 3 minus 2 is 1, 15. 3 times 5 is 15. So it equals 45%. Mommy. Hang on, guys. Okay, so now let's look at the total votes for girls. And we're looking how many votes Dora received out of all of the girls. So we're going to put Dora over girls. So this is another part to part. So Dora is right up here with 150 votes out of a total for girls. So we have Becky received 105, Dora at 150, and then Trisha at 120. So let's add all those up. 5 plus 2 is 7. 1 plus 1 plus 1 is 3. So 375 equals x over 100. So we can go ahead and do this the way we're used to if you guys want. So we have 375x, doing our cross product, equals 1500. Sorry, 15,000. Divide by 375, divide by 375. So let's do the math over here. So 1500 divided by 375. So let's see, 3 goes into 15 5 times, that's probably too many, so 375 times 4, 4 times 5 is 20, 7 times 4 is 28, 29, 30, 3 times 4 is 12, 13, 14, 15, so 1500 is 4 times, so it's going to be 40 times.
I read book to see.
Okay, you read a book, sweetheart.
You read book for me.
I read it to you. Okay, so 40%. There we go. So now let's compare the percents. So we have 45% for Derek and 40% for Dora. So it's a difference of 5%. Okay, so now let's move on to the next part. So what type of graph would best be represented in a bar graph? So like we've seen, categories are great. We saw votes. I've seen things like per month. So sometimes monthly segments are good. Years are going to be more usually a line graph, but months are good in a bar graph as well. Okay. Uh-oh. So what is a circle graph? A circle graph shows how a set of data is divided into parts. So, okay, sorry, back to it. So each sector or slice of the circle represents one part of the entire data set. So let's stop and think about it. If you're eating a pizza, you eat the whole thing, you eat 100%. Then this next piece is called a half, and that is 50%. And then the next segment is called a quarter, and that is 25%. So remember, though, that a circle equals 100%. It does not mean that the circle represents 100 samples. So even if it's 100%, say that you surveyed 10 people, and half of them like cheese pizza and half of them like pepperoni. So it's not that 50 like cheese, it's that only 5 do. If we totaled, oops, and Avery, you hit the next slide. Okay, so
this is the next slide.
Yes, the next slide. So it's really that 5 people liked the cheese since it's out of a total of 10. All right, so let's go ahead and practice this one. So 60 people were surveyed about their favorite type of juice. The circle graph shows the results. Use the graph to answer each question. So the first question says, how many people choose apple juice as their favorite? So let's take a look. It says that apple juice is 25%. So I know a lot of people would want to say it's 25 people, but if you go back and take a look, it says 60 people were surveyed. So how many people out of, so is over of equals 25% over 100. So set up our proportion, do our cross product. So 25% of 60. You could also do 60 times 0.5. And I'm actually going to rearrange it and put my 0.5 on the bottom. So let me do, or on the top, times 0.60. Okay, 1 second, baby. 5 times 6 is 30. 2 times 6 is 12 plus 3 is 15. One number to the right of the decimal. So it's 15 people. Okay, so sorry. What I was saying is that 15 out of the 60 people, or 25%, choose apple juice. So now it's your turn. Figure out how many people like grape juice. Okay, so now go ahead and check your work. So we did x over 60 equals 20 over 100. We got 12 people. And then besides the proportion, is there any other way to solve? Yes, you can multiply the total by the percent in decimal form. So like we did on this one here, I did 60 times 0.2 equals 12. Okay, so what does part to part mean? We already discussed that. That's a portion compared to another portion. And what is part to whole? Part is a segment of it, like for example, girls in the class to the total class. So with part to whole, your numerator will always be less than your denominator, or your first number in the comparison will always be less. But that's not always the case in a part to part. And how can you tell in a question what to do? So if it says in all or in total, that's going to be more of your part to whole. Okay, so on your own, I want you to go ahead and do, choose two. I would do the upper level and the platinum level, and then check your work. Okay, so now it's time to check your work. So I did the upper level and the platinum. So we're looking for what is 44% of 5,000, and that's 2,200 tickets. And then for platinum, it's what is 2% of 5,000, and that is 1,000. All right, so what type of graph would best be represented in a circle? I'm sorry, what type of data would best be represented in a circle graph? And we've been dealing a lot with percents, so the correct answer is percents. Okay, so think fast. Can the same data be represented in the different types of graphs? So here we have a family travel magazine compared the cost of children's ticket at the zoo. So we have it in a bar graph. We also have it in the tables. So we have the price of a zoo ticket for children here in LA, Denver, San Diego, and San Francisco. So yes, it can be displayed in different data, but what is the fastest one to read? The fastest one to be like, okay, so it's cheapest in LA and it's most expensive in Denver. I was able to see that much faster on a bar graph. Okay, so now it's time to get going and get practice on your own.